Welcome to homework.
For quantities, we need to know several different relationships between moles, molecules, atoms, and ions. So if you are given a certain quantity of moles, we know that every 1 mole of a substance contains 6.02 times 10 to the 23rd things, which is sometimes called an entity. So in this case, if we have 0.4 moles of O3 or 0.4 moles of O2, they both have the same number of particles. So these quantities are equal. If instead of asking about number of particles or entities, we ask about grams, we need to use the molar mass to compare. So if I have 0.4 moles of O3, to change that to grams, I use the molar mass. Or looking on the periodic table, I add up, or multiply in this case, 3 times the molar mass of oxygen. So 0.4 divided by 3 times 15.99999 equals 19.2 grams. Similarly, if we look at our moles of oxygen atoms, 1 mole has a mass of 15.999 grams, or 0.4 divided by 15.999 is 6.4 grams. So using the molar mass, we can see that 0.4 moles O3 has more grams than 0.04 moles of O. You can see a similar thing with different compounds. 4 grams of N2O4, changing to moles. Again, I use the molar mass, which is 2 times the molar mass of nitrogen, plus 4 times the molar mass of oxygen. Or 4 divided by this number is 0.043 moles. 3.3 grams of SO2 divided by its molar mass, which is the molar mass of sulfur, plus 2 times the molar mass of oxygen, equals 0.052 moles. So we see that 3.3 grams SO2 has more moles than 4 grams of N2O4. Given to convert to grams, it's a similar process using molar mass, except in this case we multiply by the molar mass. So 0.6 moles of C2H4 times the molar mass, which is 2 times the molar mass of carbon, plus 4 times the molar mass of hydrogen, tells us that this is equivalent to 16.8 grams. 0.6 moles of F2 multiplied by its molar mass, which is 2 times 18.998, is equivalent to 22.8 grams. So 0.6 moles of F2 is more grams than 0.6 moles of C2H4. If you're given an ionic compound asked to look at number of ions, first we have to figure out which ions make these compounds. So sodium chlorate is made up of the sodium ion, Na+, and the chlorate anion, ClO3-. So there's one ion of sodium and one ion of chlorate to make sodium chlorate. So if I have 2.3 moles of NaClO3, this is equivalent to multiplying it by 6.02 times 10 to the 23rd formula units. Formula unit is just one ionic compound unit per mole. And I know that there are 2 ions for every formula unit. So multiplying 2.3 times 6.02 times 10 to the 23rd times 2 tells us there are 2.77 times 10 to the 24th ions. Similarly with magnesium chloride, magnesium is made up of Mg2+ and Cl-. So the formula is MgCl2. There are 3 ions, 1 magnesium and 2 chlorines. So if I have 2.2 moles of magnesium chloride, changing that to formula units, and then multiplying by 3 ions for every formula unit. This equals 3.97 times 10 to the 24 ions. So there are more total ions in 2.2 moles magnesium chloride. Look at molecules in a certain quantity. We have to change grams to moles to molecules. So 1 gram of H2O is changed to moles by dividing by the molar mass, which is 2 times the molar mass of hydrogen plus the molar mass of oxygen. And then changing to molecules by multiplying by Avogadro's number. Similarly, the same steps for H2O2 or hydrogen peroxide. The only difference is the molar mass. 1 mole is equal to 2 times the molar mass of hydrogen plus 2 times the molar mass of oxygen. And then multiplying again by Avogadro's number. Or 1.77 times 10 to the 22nd molecules. So there are more molecules in 1 gram of water than there are in 1 gram of hydrogen peroxide. And if we're given an atomic symbol U-235, this means that the atomic weight is 235 atomic mass units, as opposed to a mole of uranium-238. And so this has a slightly larger mass than this. So subsequently, U-238 will have more mass than U-235.